I'm here to give you the latest outlook in terms of the climate predictions for this growing season, and this is a follow-up to meetings that were done here several weeks ago, and we're trying to at least keep people updated on what the potential for climatic conditions across the United States and areas that we may see some potential problems. And for the first slide, we will note that over the last 60 days, and basically looking at the period from the 1st of December through the end of January, we have seen a dominant pattern of below normal temperatures over the northwestern United States, extending eastward through the Dakotas and then southward along the front range of the Rocky Mountains. And this is in direct response to a very active weather pattern that has developed emanating out of the Gulf of Alaska as an upper air low that is a regular feature of the pattern in the Aleutian Islands, has gotten stronger as the winter has progressed and deepened enough that systems rotating around that semi-permanent area of low pressure have been able to spin energy into the western United States, and we've seen a significant uptick in the precipitation coming into the western United States and the cold air penetrating in to portions of the northwestern United States. But further to the east, as we look down into the Gulf Coast region, we will notice that the last 2 months have been unusually warm, as for most of the eastern half of the country. The greatest departures from normal are across the southeastern United States. We're running on an average of 6 to 8 degrees above normal along the Gulf Coast, running about 4 to 6 degrees normal in the mid-Mississippi and the lower Ohio River Valley. And then as you get up into the eastern Corn Belt, running about 2 to 4 degrees below normal. As we go to the next slide, we will notice that in terms of precipitation, there's a couple of pretty significant patterns over the last 60 days. First and foremost is the unbelievable amount of moisture that has surged from a southwest to northeast direction from California northeastward into the western Great Lakes region, with multiple areas, particularly over the highest elevations of the Rockies and the Sierras, where we're over 200% of normal precipitation during this 60-day period. And as you go out into the central and northern plains, we see a similar response, with the central plains being slightly less than this 200% of normal precipitation, generally between 125 and 200% of normal. But there is one core dry area of immediate concern, and this would be the area from eastern Oklahoma, northeastward through central Missouri and west central portions of Illinois. To the south and east of this area, we do see some signatures of dryness, particularly over northern Alabama, all the way through the front range of the Appalachians up into the northeastern United States. Several lows that have come out of the western United States have been able to break away from that mean trough and slowly drift across Texas and then get lifted across the Gulf Coast regions up the eastern seaboard. But as you look at the count since December, only about 1 out of every 4 storms has been able to take this path, and the path has not been consistent with these upper air lows. Therefore, you'll see that there's areas like in extreme southern Georgia where we're exceptionally wet, yet just to the north of there we're dry, and then we see another area basically over Tennessee and Kentucky that are warmer or wetter than normal. So when we see these lows coming out, we're not getting the same areas hit with precipitation, and we get this scattering of precipitation throughout the region with not uniform distribution. And this is a concern as we go to the next slide and we start to look at the fall temperature pattern. This is an area that, again, not only is in the 60 days been warmer than normal, but as we go out through last fall was warmer than normal, as was most of the lower 48, with the highest concentration of above normal temperatures situated in the central part of the United States, running anywhere from Oklahoma up to the Dakotas, anywhere from 4 degrees above normal to about 8 degrees above normal. But if we look at the next slide, what we will notice is that southeastern United States area that has shown a tendency to have a skipping fashion in terms of the areas of above normal and below normal precipitation has a much more widespread signature in terms of dry conditions. We're looking at areas from eastern Texas all the way through the southeastern United States, except for, of course, the area immediately adjacent to the Atlantic seaboard in the Carolinas that have seen less than 50% of normal moisture last fall. And then the other area that we see a significant signature of dryness is, of course, southwestern Kansas, the Texas Panhandle, and portions of eastern Colorado. This area has seen at least a semblance of precipitation over the last 2 months, with the most concentrated impacts of precipitation associated with the massive ice storm that hit about 3 weeks ago and brought almost a full winter's worth of precipitation to much of the Texas Panhandle and southwestern Kansas, but missed a substantial portion of east central Colorado or northeast Colorado. So we're still carrying some residual dryness from last fall, and that's one of the reasons why we have not seen an aggressive weakening of the drought monitor impacts for this region. We'll also notice that a pretty significant amount of moisture come into the Pacific Northwest last fall, and most of that moisture moved again from a southwest to a northeast direction, primarily impacting the areas of northwestern Wyoming, Montana, and the western Dakotas. And in fact, some of the early season snows that we've seen in the northern plains hit primarily North Dakota, and we're seeing in the Fargo area still a significant snowpack on the ground, and this area received well in excess of 50 inches of snowfall during the first half of the winter. It's been dry recently, but if the jet stream begins to lift back toward the north, as we typically see at this time of the year, the lows that are coming into California would be expected to move across this region. More of a concern for eastern Nebraska and the Central Plains is the tail end of that southeastern drought area. This would be the area of eastern Oklahoma and Texas, where we did see a dry signature. Now, recent precipitation in Texas is helping to alleviate this situation, but most of the area of eastern Oklahoma has missed out on many of these precipitation events coming into California. So, with keen interest, we're watching these upper air lows that are moving through the Texas region here in the most recent week or two, because some of that precipitation shield has started to move up into eastern Oklahoma, and we should see some recovery from this area. How much recovery will really be dependent on how quickly these storms come across the country and how long this pattern of storms moving in the western United States continues in through the spring period. If we see the storms start to subside rather dramatically as we move through this next 30-day period, then this drought signature in eastern Oklahoma will be one to watch to see whether or not it impedes the amount of moisture flowing from the Gulf of Mexico northward into the Central Plains that frontal boundary passages are able to work on and generate precipitation during normal spring patterns. This would be the most significant area of concern at the immediate time within the Central Plains. Now, as we go to the next slide and take this out to a scale that includes the tail end of last growing season and, of course, the recharge of this fall and the most recent precipitation trends, we can still see that there's a fairly significant signature in eastern portions of Colorado. You can see that over the 6 month period, even though we had intense dryness in the fall in the panhandle of Texas and Oklahoma, that much of that signature is not within the 6 month category, meaning that we've had a dry period in between two wet periods. But more importantly, when we look at all time scales from 60 days out to 6 months, the areas of the southeast continue to show a strong dry pattern, and that area of Arkansas, Oklahoma, and Missouri also is exhibiting a similar pattern. And the big question is, does this area merge and expand as temperatures increase, dormancy breaks, and the area basically east of Oklahoma is dominated by forests, which usually break dormancy much quicker than the crop that uses water in that area typically sees an uptick as we go through the spring. What we're saying is that the lack of deep subsoil moisture is a concern, because trees are very efficient at pulling surface moisture, but they also have deep tap roots to take deep subsoil moisture out of the profile. And if we start to see the lack of moisture in our deep profile, that means the moisture at the surface gets used up rather quickly by these forested areas, and we would start to see our relative humidity levels drop as we move into the spring period, which would impede to some extent the flow of moisture moving northward into the eastern corn belt and potentially cause them problems as we get down into the summer months. So as we go to the next slide and take this out to 12 months, really what we're looking here is areas that are prone to see the likelihood of hydrological aspects of drought. When we get to 12 months and beyond, we usually reflect this in our stream flows and our groundwater tables. So you can see that area of the southeast continues to stand out like a sore thumb. It is exceptionally dry, and anytime we're less than 80% of normal precipitation from 6 months out, we have a fairly significant drought in place. But more importantly, we still see that same signature of dryness in that area from southeastern portions of Iowa and southwestward into eastern Oklahoma. So we have two pretty substantial areas that have a small bridge of above normal moisture right along the Mississippi River Valley, and those areas have the potential to merge again as we go into the summer months if we do not see a good precipitation pattern during the spring period. As you look out into the west, you can see the impacts of the aggressive moisture pattern that we've seen in the last 2 months in the western United States as being reflected as above normal moisture in all of the mountain basins, particularly the Central Rockies and the Sierras, where last year was a decent year for rainfall in the northern half of the Sierras, but we have seen such an aggressive pattern of over 200% of normal moisture these last 2 months that have overwhelmed even the long-term dryness issues. So when you look at these maps and you see in the western United States, particularly from Colorado westward, these pockets of dryness, realize that these are in the lower valley regions and that most of the moisture that's being reflected as above normal within the western one-third of the United States is really picking up what is going on in your mid layers of the elevation, basically 5,000 feet and above, which is picking up a lot of our snow measurements. So as we go to the next slide, the one thing that we've noticed with the most recent warming pattern has been that we're losing the snowpack along the front range of the Rocky Mountains with this warm stretch. We still see a fairly significant area of snow up in the Dakotas. This is not likely to disappear anytime soon, and that the vast majority of heavy snowfall in North America lies essentially from Ontario eastward, with the heaviest of the snowfall on the ground currently just to the east of Lake Superior and Lake Huron. But further west, we can see that most of the snowfall that is reported in the western United States is really in the mountains, with very little of it in the elevations of below 5,000 feet. As we go to the next slide, we can look and see what the snow water equivalency of the Sierra snowpack is. This is very important because this is an area that's been in persistent drought, and with the heavy precipitation and some of the issues with some of the dams in California, the concern is that with the amount of water that we have in this snowpack and how widespread it is, that if we get an semblance of either warm storms coming in to throw warm rain on top of a snowpack, or we get an aggressive building of heat, that we will get a rapid runoff of this tremendous snowpack, and it will make it very difficult for water managers to be able to handle this runoff. Right now, the current estimates are that we have somewhere around 35 to 40 inches in the snowpack after this recent series of storms. And if we go to the next slide, we can kind of see the average of the Sierra snowpack over time. So we've had these step-stair fashion in terms of the impacts of these storms. We get a continual train, and they build the snowpack up. We get this brief break in the snowpack accumulations periodically. At those times when we get these periodic breaks in the snowpack, that's when we typically see much colder conditions coming into the Central Plains, as the troughs that are responsible for the lows coming into California pass east of the area, and then are able to tap some of the cold air up in Canada on the backside. Once we start to see the activity increase in California, we start to see ridging building up in front of those troughing patterns coming in the western United States, and that pumps the warm air into our region. So this frequency where we're seeing a switch between colder and warmer conditions is likely to continue. As we look at the numerical models, there's really nothing out there that suggests that this pattern is going to break down anytime soon. So we would expect as temperatures begin to increase, as normally we see at this time of the year in the southern plains, that will help the atmosphere hold more water vapor. And if these lows are coming into California on a regular basis, as they have been for much of the last 2 months, then we would expect the precipitation events to start generating more significant moisture at the surface in the central and southern plains as these systems come out. The major concern at this point in time is how long of stretches of warm weather do we get as these storms hit the western United States before the cold air comes in. And the reason we're concerned about that is as we go into late February and early March, we really don't want to see our vegetation break dormancy early. We'd rather it be kind of close to normal. This would keep essentially our grasses from growing. It would basically keep the water that is in the profile that we're accumulating basically locked into place without it being used too early. And it allows us the opportunity to accumulate more infiltration from precipitation events. If we were to break dormancy too early, we're going to start using some of that water that we may need as we get later into the growing season. And so the best thing that can happen to us at this point in time is just to see a continuous stream of storms coming across to give us the moisture necessary to eliminate some of the dryness issues, particularly across the southern half of Nebraska from essentially Grand Island westward. Now, as we looked at the next slide, what we will also notice is that it's just not California that's getting hit with the recent storm activity. We're seeing very significant snow accumulations in all areas, essentially from California eastward through central Wyoming and southward through essentially central portions of Arizona and New Mexico. But if we get south of that area, we're below normal in terms of snowpack. If we wanted to use a proxy so far for this winter and looking at the total coverage of snow in the central and southern Rockies, you really got to go back to 1982, 1983 winter to see such a similar type of a pattern over such a broad area. It's not unusual for us to see heavy snowfall in the central and northern Sierras and yet see nothing of any consequence in the southern portions of the Sierra, and the same thing with the central and northern Rockies. Generally, we will see an aggressive pattern over one portion of the Rockies where the other portion of the Rockies misses out with most of the major storm events. And we can see the same pattern here on this map. Most of the storms coming into California point southward. During the first part of the winter, we were seeing an aggressive pattern across the northern Rockies. So as these systems continue their presence, and if they continue as forecasted by the models, we should see this snow area lift toward the north and start to see an aggressive snow pattern developing over the Pacific Northwest and the northern Rockies as we move into the months of March and April. And this is the time of the year when they typically see a lot of their significant snow activity along with blizzard formation. So we still got a ways to go. We're not really concerned at this point in time with the subpar snowpack in the northern Rockies. There's been significant systems coming in on a regular basis, and if this trend continues, we will see some pretty significant improvements in the northern Rockies. So overall, the snowpack across the Rockies looks good. One of the primary forecasting tools I've used for western Nebraska has always been looking at the Platte River Valley, particularly central Colorado up through central portions of Wyoming, looking at the snowpack. And one of the things that we've noted is as we get into the last official release by the Natural Resource Conservation Service in the month of May is to see whether or not the snowpack is less than 80% of normal. Typically, if we're less than 80% of normal snowpack, we tend to see drought develop rather rapidly across the central Rockies and start pushing toward the east and start to impact the western one-third of Nebraska. But based on this snowpack and based on what the current estimates are, we don't see that as a problem in the immediate future. In fact, I think the biggest issue would be if these storms continue in their present fashion and we're entering the two typically wettest months of the snow season for Colorado and Wyoming, that is the months of March and April, that is likely that these snow values that we're seeing here on this map will continue to be in the 100 to 150% range. And if that is the case, we would expect at least a minimum of 1 million acre-feet of runoff coming to the northern branch of the Platte. Right now, there's about 650,000 acre-feet of storage. As long as this doesn't all come at once, we'll be able to manage that water fairly easily. However, if we replicate the last couple of winters, meaning a very late snow season continuing on through March and April, and seeing significant accumulations in that snowpack during that 2-month period, we could possibly see much more significant runoff potential and, of course, total water volume moving through the system, meaning from 1 million acre-feet, it would not be unheard of with an aggressive snow season to be above 1.5 million acre-feet or greater. So the big wild card in this is what the next 2 months are going to do in terms of the snow season, and secondarily, what will happen in the area that is funneling moisture through the southern branch of the Platte, simply because those high flows on the southern branch of the Platte will give less room for CNPPID operators to manage the water behind McConaughey. With high flows on the south branch,
it's less water that they can release downstream without causing lowland flooding. And that's the major concern going forward, is that we get a late season of snow and then it overwhelms the system, and then we have high flows on the Platte all the way through the spring and in the early part of the summer as they try to manage those snow melt waters coming in, at the same time trying to manage your normal precipitation patterns that you see in the Central Plains. So if you have high flows and you follow up with a high rainfall event, you're just going to compound the flooding problem. So this is an issue that's going to be with us all the way through the spring period. Now, as we go to the next slide, the one thing that we will notice is that there has been significant reductions in the drought across the United States. Most importantly is California. Complete elimination of the drought in the northern half of the state. We are now working on elimination of much of the drought signature from the area from San Francisco to LA. Most recent quantitative precipitation forecast with storm systems coming in over the next 7 to 10 day period as we enter the final 2 full weeks of the month of February is essentially pointing to the potential of the area that's currently depicted in drought, particularly that little red area just south of LA, which is currently the only D3 area in the state, is a bullseye for 10 plus inches of moisture over this next 7 day period. So the expectations are that much of the central and southern California will once again see further drought reductions in the drought monitor as we go through this next 10 week or next 2 weeks, excuse me, and we're likely to see at least a 1 category reduction over a vast majority of this area. Further closer to Nebraska, we still are carrying a long-term deficit in eastern Colorado. We pointed that out on various precipitation timescales, along with some encroaching dryness issues in portions of the southern panhandle and southwest Nebraska, with a longer-term dry signal for much of central and south central Nebraska due to the very poor precipitation pattern, primarily from the second half of last summer on. And then, of course, you see the drought in the southeastern United States has been basically a part of the drought monitor for the better part of the last fall period and all the way through this winter. We've seen this area shrink by about 50%, but we are still carrying a couple D3 pockets and a substantial area of severe drought. And that's reflected both in long-term indicators, even though short-term indicators have been wet. They really haven't been sufficient enough to completely eliminate this drought. And if you consider that within 6 weeks, this area will be primarily have the row crops growing, actively growing, we are probably looking at less than a 1% likelihood of drought removal over the 6 week period. And if you wanted to completely remove the long-term drought signal, some of these areas over the last 6 to 12 month period are accumulating deficits in excess of 20 inches. So normal moisture going forward is about an inch to an inch and a half a week in this region over the next 6 weeks. If you wanted to completely eliminate all drought signature, you'd be looking at the worst core areas of D3, probably needing 25 inches of moisture to completely undo the situation and recharge groundwater aquifer sufficiently that you would lose that long-term drought. It's highly unlikely that that will happen, and so this is an area of focus as we go into the spring to see whether or not, as temperatures increase and water use increases, both by native vegetation and agricultural crops, whether this area starts to build rapidly toward the north. So as we go to the next slide, of course, taking the forecast out into the future, the one thing we'd be looking for is that area of the Equatorial Pacific, particularly that cold pocket that is the last remaining vestiges of what was predicted to be a La Nina-like conditions. This area has basically been in play now for the better part of the last 3 months, and it has not met the criteria of an official La Nina and has been showing signs of dissipating. Further north into the North Pacific, we see an area of warmer than normal conditions. This was 6 months ago. And essentially, this area that is showing the above normal sea surface conditions in the Gulf of Alaska has been replaced by colder than normal conditions, while the Atlantic remains warmer than normal. We'll talk about that interaction between the Pacific and the Atlantic in a couple more slides, but we want to concentrate on the area of the Equatorial Pacific. The global numerical models have now just changed slightly, and as we look at the projections for the spring and the summer period, 50% of the models currently are saying that this pattern will remain neutral, meaning that we'll be within a half degree Celsius above normal to a half degree Celsius below normal for the summer period. So we're not expecting influences based on numerical models from ENSO events, meaning El Niños or La Niñas as we go into the heart of our growing season. However, the trend has been to announce these events or predict these events way in advance of what really materializes. And to give an example, the previous El Nino signature that we went through, which turned out to be the second or third strongest in recorded history going back to the 1950s, and depends on which database you look at, that basically was predicted a year in advance of it finally materializing. So the models are seeing something, but they're being aggressive in pointing out whether or not the event does occur. And so, with caution, we would like to recommend paying particular attention to Equatorial Pacific, because if we start to see the models fail in their predictability and we start to see this area growing as we go into late spring months, that would signal to me that this La Nina event's finally getting its act together and will continue to grow. And generally, events that start to grow rather dramatically at the end of the spring and the early part of the summer tend to be very significant events. However, there's only a 17% likelihood based on the models that this will occur. So it's nothing to be overly concerned about, but to keep in the back of the radar, because typical La Nina-like patterns are detrimental to the western United States in terms of moisture, but more importantly, they usually bring above normal temperatures to the region. Now, the area of the North Pacific and the North Atlantic interaction is a well-known phenomena. This research was done back in the 80s by the University of Oklahoma, looking at mechanisms that may cause drought problems across the United States, and they found significant correlations between the Gulf of Alaska, the PDO, which defines the Pacific Decadal Oscillation, and the North Atlantic. So as we go to the next slide, one of the things with the El Nino region is that we've seen this area shrinking up over time. And of course, this area is showing in the first part of December, an area of the Eastern Pacific colder than normal and the Central Pacific colder than normal below the surface, and depths running anywhere from 50 meters to 150 meters in depth. What we do know is the most recent updates is that most of the area in the Eastern Pacific cold pocket below the surface has completely disappeared, and we've actually seen a spattering above normal temperatures starting to show up in portions of the surface of the Eastern Pacific, and we've lost about 50% of the volume of area underneath the Equatorial Pacific that has been showing below normal sea surface temperatures. It has stabilized over the last couple of weeks. We're not showing further deterioration, but we're not even showing any further expansion. So if this pattern continues, most likely the ENSO neutral conditions will be the favored complex for this summer, meaning we're not expecting those to be driving forces, either La Nina or El Nino, at least through this growing season. So as we go to the next slide, it's basically a consolidation of all these models. And you can see the vast majority of them, basically, as we take these all the way out into the fall period, are between a half a degree Celsius above normal and a half degree Celsius below normal. And only a couple of the models fall down into just below that -5 degrees Celsius below normal, which signify potential La Nina-like conditions. And then about 3 of the models take us above that half a degree Celsius mark before the end of the summer. And if that does indeed materialize, then of course drought concerns would be more important to portions of the central and eastern corn belt than they would be to the western corn belt if we move into El Nino-like pattern. So if we look at the upper air model, this is basically the most current forecast for generation. And one reason I like to show this slide is simply because we can look at the upper air lows as they come into the western United States and kind of get an idea of how they're passing through the country. And the system that we're showing here in California, you can see that it kind of has a little dip underneath of that flow, which signifies this is a southern stream. And then if you look to the north, there's a blank area over the Pacific Northwest before we see the ridging pattern and the true northern jet displays to us north. So these lows have been doing one of two things. They're either kicking out toward the northeast, which has been the general trend, or every now and then one of these slowly migrates toward the Gulf Coast region and weakens as it moves eastward, leaving less precipitation at the surface in the southeast than we're seeing in the state of Texas as these lows pass through. The most important criteria in terms of the jet stream pattern is that there's just a continuation of storms, and more importantly, as we move into the last part of February and the early part of March, the models are indicating that this train of storms will continue and that it'll bring aggressive precipitation to much of the eastern United States. So if we go to the next slides, which takes us out to 11 to 16 days, you can see another one of these storms coming into California, and there's a little bit of ridging behind it pushing into western portions of Canada, but right behind that is another series of lows that as we go through this period will move right across the center part of the country, which increases our likelihood for seeing significant moisture beginning here in these next 2 weeks and carrying on into the early part of March. But more importantly, there's increasing signs that a cold air is going to get drawn behind these lows into the western United States and be available for potential snowmaking as we go into the latter part of February and early March, meaning the cold air will get pulled toward the east and interact with these lows that are expected across the center part of the country. So we should see a significant uptick, at least in the short term, with moisture events. And as we move toward the last full week of February and into the first full week of March, there appears to be more cold air going to be available over the western United States to generate snow in portions of the central and northern plains. So calving season may get a little bit interesting here as we go forward over the next month. As we go to the next slide, this is a new experimental forecast that has been put out by the Climate Prediction Center. It put out last fall. And I want to show you these slides simply from a standpoint that we've been watching these, and they've actually been more accurate than the 6 to 10 day and 8 to 14 day forecasts, as they're just catching a more generalized trend. So we may or may not believe these forecasts, but they are what they are, and it kind of gives you an idea of at least what the models are thinking over this next month. So basically, 2 weeks ago, the issue for the second half of February was for above normal temperatures for all areas except for California, which we're seeing those storms coming in on a regular basis. The latest update that was issued on Friday shows that pocket of cold air starting to develop across the western United States, lying on the eastern extent across the northwestern the northwestern half of Nebraska, and then we see the warm conditions continuing over the southeastern United States. So based on this pattern, you can see that everything's still moving from a southwest to northeast fashion in terms of temperature, and we would expect that the lows would follow a similar trajectory, which means there's enough cold air with below normal temperatures in place that anything that moves through this channel between these two pockets of warm air is likely to generate some pretty significant moisture, and on the west side or the northwest side of these storms, most likely to be in the form of significant snow. As we go to the next slide, what we will notice is 2 weeks ago, the indications for the second half of the month is for a series of storms that come into the western United States and lift toward the northeast and bring above normal moisture to the central plains, including all of Kansas, Nebraska, and the southern half of South Dakota. Current model projections continue that trend as we have a series of storms coming in. But more importantly, as we move out the tail end of February into the first part of March, aggressive snowfall and moisture is projected for the central and southern Rockies, with them bringing these storms across the southeastern United States. This will be one to be interesting to see whether or not it verifies, because this would give some additional relief to the southeastern drought area. But the persistent pattern from the models has been one where the eastern half of the southeastern United States has been under the influence of dying low pressures that have been moving through the southern stream and weakening as they move eastward. So we may be seeing an overemphasis of above normal moisture in the southeast. Time will tell. But more importantly, it appears that we'll see a drying pattern start to materialize across the western United States. And we'll be watching this with key interest to see if this continues out in through the middle and late portions of March with some subsequent releases of these experimental 3 to 4 week forecasts. Because if this pattern continues in through the middle and end of March, this would signify that we're starting to see the development of high pressure in the western United States, and that maybe the precipitation pattern that has been inundating California is coming to an end. But we can't take and look at one single 2 week period and push the entire pattern back off of into the back chapters of the book. We need to see this verify for several runs so that we get into more than just a 10, 14-day stretch of dry weather. Because if you look at the slides that we showed much earlier in this session, there's a stair-stepping fashion of storms that come into California, and every time we've had a lull in activity is when we have brought in our cold air into our region. So if we are seeing the formation of a ridging pattern starting to develop in the western United States, that would lead us to believe that we will see a downstream troughing pattern, and most likely that troughing pattern will be pulling that cold air out of California or out of Canada into the central plains in the eastern United States as we move into the months of March, which would probably pull our pull our winter period a little bit longer into the spring period than we'd feel comfortable with. Which means that if you're a cattle operator, most likely this is signaling the potential for a very strong type of weather pattern developing during the month of March that would favor much colder Arctic air outbreaks into the areas east of the Rocky Mountains, and unfortunately an uptick in snowfall, particularly across the central plains. So as we go to the next slide, we notice that the 90-day precipitation outlook is also indicating the rise of that jet stream toward the north, and most of the storm activity processing its way eastward across the northern one-third of the United States. This is almost a return to the type of precipitation pattern that hit us last fall and early part of the winter in the Pacific Northwest and the northern Dakotas. So this type of pattern would bring more associated snowfall to this region, and unfortunately you would be hitting areas of the Red River Valley that already have probably an elevated flood risk. This would just add fuel to the fire. More importantly, as you pass into Minnesota and the upper Great Lakes region, this is an area that has been persistently wet in timescales from 1 month all the way out to 6 to 8 months back into the future, back into the last growing season. So essentially from the middle of growing season forward, we've been aggressively wet. Profiles are full of moisture in this region, particularly southern Minnesota and northern Iowa. So this pattern would lead us to concerns that we may have some planting delay issues to deal with if the pattern gets excessively aggressive. If we're dealing with a storm systems that are coming through only once a week, then there may be ample time between events in these tile ground areas to get the soils dried out sufficiently to get the crops planted into the ground. But more importantly, one thing that with the temperatures that we need to be concerned about is simply that we've seen these big oscillations in temperatures, and if we get an extended period of warm temperatures and start consistently pushing up into the 70s and possibly even the low 80s in the central plains, it will not take long to break dormancy. And then seeing these big extreme oscillations in temperatures, that sets up a freeze risk, particularly for the wheat crop, the central and southern plains, that has really probably broke dormancy over this last 10 days with the very warm conditions in the southern plain, and would be exceptionally vulnerable to freeze damage, particularly if we start to see something coming in late March and early April. So if we go to the next slide, the one thing we'll draw attention on the 90-day outlook is they do keep cold conditions to our north. And to me, this is an important part of the forecast. If it verifies with above normal moisture, we would be looking at more significant likelihood of snow accumulations in this region, which means anytime the winds shift from a northwest direction, they'd be coming over this snowpack if we can develop one here this spring once again, and that would tend to temper some of our temperatures, at least in the springtime. Coming over that cold air would tend to modify them toward the lower side of the equation, not to the upper side of the equation, and would hold some of the aggressive heat from the south from overwhelming the central plains. Now, as we go to the next slide, the National Drought Monitor outlook also indicates that the aggressive moisture pattern in the western United States is foreseen to continue as we continue to see improvements in California. But more importantly, we also see improvements in the area of western Kansas, southwestern Nebraska, and the western Dakotas. However, the area eastern Oklahoma and portions of Missouri are continuing to show a stable drought pattern, not much in the way of improvement. So by all methods that we can look and analyze in this data, it appears that the Climate Prediction Center is basically putting a consensus forecast, meaning persistence in a forecast for precipitation with storms moving from the southwest to the northeast and bypassing this area of Missouri and eastern portions of Oklahoma that have been persistently dry for the better part of the last 6 months. Now, as we go to the last couple slides, we'll draw your attention once again to the most current sea surface conditions. You can see that cold pocket developed in the Gulf of Alaska. It is a pretty firm foundation. It takes a considerable amount of time for this to disappear. So by all accounts, we expect this cold pocket to be in play as we go into the spring period and particularly into the summer. But then when we look at the Atlantic, we see much warmer conditions across all but just a small pocket east of Greenland. So that we are in a warm phase of the Atlantic, and then if we look at the interaction of these two ocean basins, particularly when we're not in an El Nino or La Nina, we can start to see some risk factors associated with this type of pattern. This research was done in the early 80s by the University of Oklahoma, and essentially what they looked at was if you wanted to randomly select any year and look at the lower 25% of the precipitation percentiles based on historical precedents, just randomly selecting any year, you've got a 1 in 4 chance of being in that lower 25%. However, when the Pacific Ocean is in a cold phase and the Atlantic Ocean is in a warm phase, we start to look at the lower right-hand map, which defines our risk. And so what the University of Oklahoma did was took all of those lower 25 percentile precipitation years and then matched them up with the ocean patterns that could potentially occur. So you can have a warm Pacific and a cold Atlantic, a warm Pacific and a warm Atlantic, a cold Pacific and a cold Atlantic, and a cold Pacific and a warm Atlantic. And if we look at the lower right-hand side, this is what describes the pattern in terms of risk going forward. Does this mean that these red areas will see drought? No. What it does is signify is your drought risk increases under this type of a pattern. So for the eastern Corn Belt, what typically happens is as a jet stream lifts toward the north, we see that dryness pattern from the southeast start to build northward as the ridge starts to amplify toward the north, cuts off the moisture flow for this region. But as that high pressure continues to build north, on the backside of that high, we see the circulation around the high being in a clockwise fashion. That would tend to pull some moisture off the Atlantic and feed it underneath this high pressure system and then channel it between the high pressure system that usually develops over the Rocky Mountains. So for the eastern Corn Belt, the highest odds for dryness conditions are essentially in the Tennessee River Valley. And we're really looking at a fairly good signature of about 1 in 2 chance under this type of scenario that you would see dryness issues. And then as you go up into Ohio, Indiana, and the eastern portions of Illinois, probabilities drop off into that 30 to 35% range. So you see about a 40% increase in your drought risk based based on this type of a pattern compared to what you would get in any random year. More importantly, the area that we watch here in Nebraska is that area of the Rockies, and you'll notice that the highest probabilities of a 1 in 2 chance are assigned to the southern portion of New Mexico. Once you get into the central Rockies, we're basically anywhere from 30 to 35% in the upper Platte River Valley for a risk. So that's about anywhere from a 20 to 40% increase in your risk factor. But the one underlying condition this year that may make this less likely to occur is that we have a very strong snowpack with the potential as we go forward in time to see an aggressive snowpack developing if the forecast for above normal moisture continue as expected in the central Rockies. It's highly unlikely that a vast majority of this risk area will verify out, and this will probably be one of those years where the risk associated with this type of a pattern is much less than it would be if we were running below normal snow. That being said, if these next 2 months of snowfall in the Central Rockies turn out to be a bust, these probability levels become into play rather dramatically. So, in conclusion, the things that we are looking at as we move through this next 3 to 4 month period is calving season is upon us and will rapidly increase as we move through this next month. And we expect to see extreme temperature fluctuations based on the periodicity of storms coming to the western United States and the thought that as we go forward in time, these lows are going to start targeting more central and northern California, moving across the central Rockies into the central plains. Therefore, this recent streaks of dry weather has been very welcome, and also with the above normal temperatures has been welcome for at least alleviating some of the initial problems with muddy feedlots. However, because we had pretty significant rainfall across east central and southeastern Nebraska, or northeastern Nebraska last fall period, particularly during that late summer and into the early portions of October, we got plenty of moisture at the surface that every time a precipitation event comes through is likely to uh, bring this problem to the forefront. That we'll probably be dealing off and on with these muddy feedlots until we can get temperatures consistently up into the 70s and above. The excessive wetness impacts are probably the most important in the areas of the upper Midwest. The Red River Valley has an increased flood risk, as do the areas of southern Minnesota, northern Iowa, southern Wisconsin, and northern portions of Illinois. This is an area that was aggressively wet during the second half of the growing season that actually needed to see the dry weather materialize in October for them to get out in the fields to do the normal harvest activity. They were being delayed simply because of excessive wetness. So these areas are coming to this growing season with a full profile of moisture. If the storms are active and we run these from a southwest and northeast direction for the next 2 months, as the previous 2 months have been, this area will likely see significant issues in terms of extreme wetness, potentially delaying the planting of crops. We're not calling for prevent plant, but may push the planting of those crops later into the season, of course, pushing the maturity of those varieties and the reproductive phase of those varieties farther into the summer, which means that their risk for dryness issues increases. The other thing that we watch for is if the pattern of wetness continues all the way through May and into the early part of June, then we start to look at what the impacts are on rooting development of the corn crop. And one of the major problems for the central and eastern corn belt is an aggressively wet spring followed up by extreme wetness into the first month of the growing season. It can set unfavorable rooting development, meaning your roots are contained toward your surface. And then if you get hit with a hot, dry stretch of weather, the impacts would be much more significant and much more rapid simply because your roots are extracting moisture out of a much narrower confined soil profile than they would under normal conditions where they would go down 5 or 6 feet and did take the moisture out of that profile at a fairly even rate. The snowpack looks favorable in the central Rockies, but we still have the 2 wettest months ahead of us. As they go, so goes our flood risk on the Platte River. If we're above normal in terms of snowpack, we would expect much more significant inflows into the reservoirs and a much more dire situation in terms of managing that water as we go into the snow melt season. If these 2 months turn into a bust, then we start to look at the central Rockies as a focus area for the expansion of the high pressure ridge over the southern Rockies toward the north, and particularly if the snowpack is less than 80% of normal in the central Rockies as we go to last release in early May by the NRCS. There is no undoubted certainty in terms of the upper air pattern favoring severe weather, and particularly in tornadic activity. Southwest rejecting lows into the central plains have always brought severe weather to the central plains. And if we are going to get a continual train of these storms, what we are looking for an above normal tornadic year, particularly in the central United States. The La Nina demise has been predicted. In fact, the Climate Prediction Center has now put on alert to cancel their advisory for La Nina conditions. The expectations is a 50% likelihood of neutral conditions this growing season, with only a 33% of El Nino developing toward the second half of the summer and a 17% likelihood of La Nina developing as we move through the summer and into the fall period. The one thing we'll watch with keen interest will be whether or not the cold pocket in the central Pacific continues to shrink over these next 2 months or starts to show an expansion as we get into the month of May, which would signal that we have the potential for La Nina formation and intensification during the summer months. Again, the odds at this point in time are less than 20%. The most favorable connection, if we're in ENSO neutral conditions, meaning no El Nino or La Nina, is the connection between the Pacific Decadal Oscillation and the Atlantic Meridional Oscillation. So we're looking at the Eastern Pacific to see if it's colder than normal, which it is, and is likely to continue, and the northern half of the Atlantic to see whether it's dominated by warmer conditions, which it is. So when we do a risk analysis, the highest risk analysis for dry conditions favors the Eastern Corn Belt. The second area of concern is the southern and central Rockies. That is more dependent on the amount of snowfall that occurs. So a favorable snowpack over the next 2 months
would decrease the drought risk for these areas, whereas a loss of significant snow over the next 2 months from a reduction in storm activity would certainly increase the drought risks in this region. And then finally, really what it all boils down to, if we're aggressively wet here for the next couple of months, is what is our summer temperature pattern going to do? Are we going to remain persistently cool over the western United States, or are we going to see a ridging pattern develop and overwhelm the system and bring back the heat that was common the last 2 summers in the western United States? As long as the moisture continues in its present fashion, we are likely to see this area's temperatures suppress significantly this summer, especially when you consider the amount of snow at the higher elevations. So in conclusions, it looks like we are looking at a very wild and wacky spring weather pattern based on the aggressive storm activity in the western United States, but we also recognize that the Pacific and the Atlantic connections do indicate an increased risk for drought conditions, possibly developing and expanding from the southeast toward the eastern corn belt. And for our area, the major area of emphasis under this type of a pattern is to watch the area of central Missouri, southwestward into eastern Oklahoma, to see if that region connects in with the southeastern drought and whether or not we see that try to expand toward the northwest as the summer progresses. If that does occur, then we would see the most likely impacts from drier than normal conditions really start to become problematic as we go to the second half of the summer, which would be more problematic for the soybean complex than it would be for the corn complex. And for western Nebraska, even if a dry pattern materializes at this point in time, we have ample water supplies from everything that we've been told by most of the major operators. Outside of some small localized watersheds, it appears that no water restrictions of any significance will be in play as we go into this growing season.